So my name is Sachna, and I'm a second year PhD student at Physical Research Laboratory, India. So today I'm going to discuss about a comprehensive analysis of four potential landing sites located in the Digarlashi-Shackleton Ridge area near to Lunar South Pole. Next slide, please. So before going to my study, I would like to give a brief introduction about the importance of this particular ridge, which is also known as connecting ridge. So this particular ridge, it is situated in between Digarlashi and Shackleton crater, and this is a highest elevated region near to lunar south pole, as well as it give an extended Earth as well as sun visibility, and it is a part of South Pole Aitken Basin outer rim, and it gives accessibility to several potential PSRs nearby like Digarlashi and Shackleton. These are potential PSRs. So based on all these things, it is selected as one of the candidate location for Artemis as well as LUPEX missions. So for my study, I have selected 4 landing sites in this particular ridge area named Site S, C1, C2 and D, starting from the right. So among all 4, 3 of them have been represented in many of the other literatures which they have mentioned Site S, C1 and C2 as the highest illuminated regions. And to this list, we added a fourth site which is named as Site D, which is located in the Digarlashi crater rim. So for any landing mission to be successful, it should land first safely, as well as it should also provide enough scientific outcomes to make the mission meaningful. So keeping this particular fact in mind, we analyzed this particular for landing site with respect to technical feasibility for landing as well as the scientific potential of all these 4 landing sites. Next slide, please. So to study this technical feasibility, we considered elevation, slope, illumination, roughness, temperature, and trafficability aspects. And in case of scientific characterization, we are going to poles. So of course, we prefer to study volatiles. So PSR is the first consideration for that. And also we studied local scale geomorphology as well as geology. So after studying all these parameters, we individually ranked them on the basis of each landing site. For example, if I take slope, we all consider landing in a low slope area like less than 8 degree or so. So if a particular landing site have a slope less than 8 degree, so it will get more weightage, like if it have a low slope area more then. So like that, all these factors were considered and it was weighted accordingly. And the highest weighted landing site is set as the final landing site, and travels have been mapped for that particular one. So for this study, we have used data from LARO mission, Chandrayaan 1 and Chandrayaan 2 mission, and the entire data have been processed using ArcGIS, QGIS, and NV softwares. Next slide, please. So the first factor is elevation. As you can see from the map, all 4 landing site is located in the highest elevated region, which is indicated in white color. And to represent the spatial variation in elevation, we have put contours for that. And you can see that for site C1 and C2, only lesser number of contour lines are passing through. That means there is lesser amount of spatial variation for these sites. For example, if you take site S, it have more number of contours, especially in the right side of the site S. So that means it represents a steeper terrain, which is Shackleton crater wall. So in case of slope, we prefer a slope less than 8 degree, which is suitable for landing. So it is represented in brick red color. You can see that site C1 and site C2 is having maximum of such area, while in case of site S, it is very limited and it is concentrated on the Shackleton crater rim. Next slide, please. In case of illumination, as I have mentioned earlier, all 4 landing sites satisfy the illumination constraints. They have been founded as highest illuminated regions in the lunar south pole, and comparing the illumination values of all the landing site C1 was coming good as it have like maximum average illumination of around 70%, and it have more area with 40% above illumination. And roughness map, it is prepared from Lola DEM data. So we prefer a roughness value below 0.4 because we prefer flatter or like more or less smoother terrains to land, which is devoid of any boulders or something. So these lesser roughness values are indicated in pink color in the right hand image. So you can see that C1 and C2 is having more concentrated lower roughness value as compared to D and S. Site S have very limited lower rougher areas because there are like lot of ejecta or boulders which are excavated and distributed in the rim area. Next slide, please. So in case of temperature, the entire ridge region is showing higher temperature value during summer, especially the site S, which shows highest temperature out of all, which is around 276 Kelvin. And in winter also, it is having highest temperature. And this particular seasonal temperature can also be used as a proxy to find potential PSRs, which will show lower temperature both in summer as well as winter. Can you change the slide? So these are some locations which show consistently lower temperature both in summer as well as winter. This can serve as potential PSRs. Next slide, please. So geomorphology map for all the landing site was prepared using the methodology adopted from Bernhard's South Pole geomorphology map. Additionally, we added boulder location to that particular map, which will aid in landing as well as rovering. So some camera images representing these major landform units is also presented here, which is taken from the OHRC camera on board Chandrayaan 2, which is the highest resolution camera so far. So according to Bernhard, the most appropriate landform to land is cratered highland surface, which is CHS. And in the map, you can see that site C2 is having maximum of this CHS area, while site S is having the minimum. Can you move to next slide? Another important aspect which we found from geomorphology map from site C1 is the presence of two putative lobate scarp. This will be very important feature to explore if we land somewhere near to site C1. Next slide, please. So to find the permanently shadowed region near to all the landing site, we compiled the illumination, temperature, and elevation data set by giving proper weightages. So in this particular map, you can see some blue regions which have a lower illumination value less than 5% and average temperature less than 110 Kelvin. Essentially, it is less than 100 Kelvin and also lower elevation. So this brown area represent the regions where we are not like expected to have a PSR. So we selected some of these blue areas which likely represent PSR surrounding to our landing site, which will be probable candidates to explore while we land in any of these landing sites. Move to next slide. So we also considered spectral analysis for our landing sites. So we focused on this 2.8 micrometer absorption characteristic of hydroxyl or water using MQ data. We found that many of our landing areas is having this 2.8 micrometer absorption range. So a maximum of this absorption was found from site D and followed by site S. And you can see that in site C1 there is a particular portion which contains a cluster of this 2.8 micrometer absorption pixels, which we are assuming that it is coming from the PSR, which we have indicated earlier. We also found that there are like cluster of hematite pixel near to site D as well as site C1, which will give it additional weightage when we are landing there. It will give enough exploration potential in terms of hematite. Next slide, please.
Under 1 minute, under 2 minutes.
Okay. So I'm concluding. So in our study, we analyzed the technical feasibility and scientific potential offered by each site. So in case of slope, we found that site C2 and site C1 is offering good slope, like they have more area within less than 8 degree. And in case of site S, which is near to Shackleton crater rim, it have very high slope and the low slopey area is very limited, which is mainly concentrated to the crater rim. So in case of roughness, we put a threshold of less than 0.4, which indicates much more smoother area. So in case of roughness also, we found that C1 and C2 is having maximum area within this threshold limit. And in case of D and S, they are more rougher because of the ejected material from these impact events. And all landing sites are satisfying the threshold put for illumination, but C1 have maximum illumination compared to all other landing sites. And in case of scientific potential, we found that all landing sites have like nearby PSRs to explore, but within a minimum distance and easily accessible range, we have PSRs in site C1 and site D. which will give them much more importance. And also these two sites have like they are proximal to the hematite deposits which was detected by Schwally. And also site C1 have two potential lobate scarps which can be explored further. So considering both C1 technical feasibility and scientific potential, C1 site was coming good. Site C2 is also coming good as in terms of technical feasibility, but it is not that much scientifically interesting. And in case of site S, it is scientifically interesting, but it is technologically challenging. Can you move to next slide? So
Please
as
go
we
ahead.
have as we have finalized site S, we proposed a traverse map for site S, and the landing point is situated in the area where we receive maximum illumination, minimum roughness, and minimum slope. And we put a traverse through the area following lower slope and highly illuminated areas to reach the PSR, which I have already mentioned. The right hand side image represent the contrast enhanced image of the PSR, which is made from the OHRC image. Can you move to the next slide? So thank you.